Okay, this is mostly another domain and range video, but I'm going to start with a homework problem that was posed on the document the other day that we did not have time to get to in class. I apologize for that. It was number 16 out of section 1.5, and specifically the question was if we could cover part B. So let's talk about that. Broadway cabs and city cars are two competing taxi companies in a small town. The cost in dollars of a cab ride of D miles is C1 for Broadway cabs, 2.5 plus 2.6 D, and here's the equation for C2. Now, first of all, let's talk about our axes. D is distance. That's our independent variable, and C of D, cost for some distance, is our dependent variable, or Y is equal to C of D. So I'm going to graph Broadway cabs first. We have let's see, a y-intercept of 2.5. So there's 2.5-ish. We have a slope of 2.6. So I don't really have a scale along the x-axis. That's not absolutely critical here. I know that the function is increasing, so I'm just going to go ahead and sketch that curve. This is C1. Now we know that C2 in comparison has a larger y-intercept of 4, so C2 will start up here at 4, but its slope is less than the slope of 2.6, so it's still increasing, but it's not increasing at as great of a rate, and so C1 and C2 will intersect out here somewhere. The question posed is, determine the conditions under which Broadway cabs, so let's see, C1 is Broadway cabs, and C2 is city cars. So where is Broadway cabs cheaper? Well, Broadway cabs is cheaper from this X value. Let me change colors. From this X value out to this X value, it's cheaper. We can see that it is less than the cost of city cars. And then once you get beyond that, city cars becomes cheaper. So I need to find my point of intersection. This is x, comma, y, or d, comma, c of d. We do that by setting the two functions equal to each other. So I'm going to say 2.5 plus 2.6d is equal to 4 plus 2.45d. I'll subtract 2.5 and I get 1.5 on the right. I'll subtract 2.45d, and let's see, that leaves us with 0.15d. I'll divide both sides by 0.15. I'll divide both sides by 0.15. And 1.5 divided by 0.15 is 10. So d is equal to 10. That tells us that our distance, the point of intersection, our distance, x value is 10. Okay? Now, if I put d back into either function, it makes no difference. You put it in here, you put it in here, you're going to get the same output. So let's say 2.5 plus 26, because that's 2.6 times 10, and 2.5 plus 26 is 28.5, and so my output is 28.5. So at a distance of 10, let's see what our unit is. Is that miles? Okay, it is miles. At a distance of 10 miles, our cost is 28.5 for both. The answer to our question is determine the conditions under which Broadway cabs is cheaper. Broadway cabs is less expensive when D is less than 10. That's our answer. Not less than or equal to, because if at 10, they have the same cost. Okay, let's jump back into domain and range now. I've got three functions. The prompt is find the domain and range of each, and I'm going to move rather quickly because I don't want this video to get too long. So I want to find the domain of k of x. K of x is 2 over the square root of x plus 1. Probably best to ask the question first. Well, we would probably plot it first, but actually before I do that, I'm just going to say, okay, I know that the square root of x plus 1 has to be, is going to result in a positive, and normally if this were in the numerator, we would say the square root of x plus 1 would have to be greater than or equal to 0, but because of where the square root falls in the denominator, it cannot be equal to 0. So we know that the square root of x plus 1 is going to have to be greater than 0. Well, what would make that true? X is going to have to be, you can pause it if you want to take a moment and think about it, but x is going to have to be bigger than -1. It cannot be equal to -1. And that's actually our domain. So our domain is x is greater than -1. We'll plot it in just a moment. In interval notation, lower bound, -1, upper bound, infinity. Notice I do not include the -1 because it says greater than, not greater than or equal to. My range, talk about that for just a moment. We know that a square root is going to be greater than or equal to 0, but in this case it cannot be 0, so because we have restricted and we said we can only put values greater than -1 in, we know that this is going to be positive. And so we have 2 over a positive, which results in a positive. Now, let's go ahead and plot it. I would encourage you to pause the video and plot the function. Y is equal to 2 divided by the square root of x plus 1. I'm plotting it off to the side right now. I'll go zoom option 6 on my TI graphing calculator, and I get a graph that looks like this. Okay, it looks something like this. Now let's think about that for a second. I know the arrows don't show up on the graphing calculator, but we actually have a range of y is greater than 0 or 0 to infinity. Neither are inclusive. And if you think about that for a moment, again, this is going to be positive, okay? But as x gets bigger, as x grows and gets larger and larger and larger, as I approach infinity, the inputs get bigger, the denominator gets bigger, and as the denominator gets really big, 2 divided by a really big number heads towards 0. We expect the outputs to head towards 0. There you go. Next example, what's the domain and range of this function m of x? Well, the first question, the easiest question to answer really is, where do we have restrictions? Where do we have problems? We have a problem if x is 0. We have a problem if x plus 2 is 0, because both of those instances result in a 0 in the denominator. So we can say that our domain, and those are the only problems, our domain is all real numbers not equal to 0 and -2. Now, the interval notation there gets a little complicated, but you can do this. We've got -infinity to -2, union -2 to 0, union 0 to infinity. Now I'm going to, again, encourage you to pause the video, plot the curve, make sure that you're getting used to plotting these curves on the graphing calculator. I'll do so right now. So y is equal to 7 divided by, hint real quick here, make sure that you wrap your denominator in an extra pair of parentheses, or your calculator is probably going to misinterpret what you're asking it to do. So I've got an extra pair of parentheses when I type this in. 7 divided by open parentheses, x times another open parenthesis, x plus 2, close parenthesis, and another close parenthesis, and I say zoom 6 generally to start. Many of the curves in our text work fine on -10 to 10 for both domain and range. Okay, and I get a graph which looks like this. There's one piece, there's another piece, and here comes a third piece. And what I'd like to point out is that you have a vertical asymptote right here, and you have another one right here. That vertical line is x equals -2, and that vertical line is x equals 0. And we already said that we cannot put 2 in, and -2 in, and we cannot put 0 in. There you go. Now, you play around. I'm going to encourage you to play around a little bit and try to determine your range. I'll give you a hint. Part of it is y is greater than 0, and then you've got this union. See if you can find the local maximum, as we call it, using your graphing calculator. And that'll give you that second piece. All right, third function. N of x is equal to -1 over the quantity x plus 1 quantity squared. Okay? Easiest way to start, again, is think about your restrictions. What can I not put in? Well, I can't put -1 in. And then I might say to myself, is there anything else that's going to cause a problem? And the answer is no. So my domain, all real numbers not equal to -1. Again, I might say negative infinity to -1, union -1 to infinity for my domain. Okay, the range, well, for all of the values that you can put in, okay, you will get something that is then going to be squared. And if that something gets squared, remember that this something, this x plus 1 can't be 0, so it never will be 0. It'll be something other than 0. Well, you square something other than 0, and you're going to get a positive. And if I take -1 and I divide -1 by a positive number, my result is going to be negative. So my gut tells me that the range is going to be values less than 0. Now, I would encourage you to plot it. I like to come up with a guess, an educated guess after thinking about it, and then I plot to confirm. So I'm typing it in, -1 over the open parenthesis, x plus 1, close parenthesis, let's see, x plus 1, close parenthesis, squared, and I'm going to say zoom option 6, zoom standard. Okay, and I get a graph which looks like this. Change colors for you. It looks like this. And that should be what you get. Notice we have a vertical asymptote at -1. We said we're not allowed to put -1 in. There it is. And our range was, as we said, our guess was all real numbers less than 0. And again, the way we state that using interval notation is -infinity to 0, not inclusive. Notice I cannot hit 0. I never will. I've got a horizontal asymptote, and so we use a parenthesis and not a bracket. All right, let's do one more for the sake of time. I'm going to cross these two out. I want to throw one more at you, though, to think about. This is a good one. It's a cubed root. Now, an alternate way to write this, just so that we're clear, is x squared minus 16 to the 1/3 power. That's the same as taking the cubed root. Notice that if I was going to type this into the calculator, personally, I just think it's a good habit to wrap that in a pair of parentheses. I'm happy to show you on the graphing calculator how to do the cubed root in this way as well, but you're being asked to find the domain and the range. Now, the interesting thing about cubed root, we have not looked at a cubed root in the course yet, is that you absolutely can take the cubed root of a negative. For example, the cubed root of -8 is -2. The cubed root of -64 is -4, etc. And that's because -2 raised to the 3rd power is -8, and -4 raised to the 3rd power is -64. So you can take the cubed root of a negative, which means that this is allowed to be negative. Whereas if it was a square root, this would not be allowed to be negative. Okay? So, think about how that applies. Well, the domain, my gut is telling me that the domain is probably all real numbers, because I'm allowed to take the cubed root of a negative, I'm allowed to take the cubed root of a positive, I'm allowed to take the cubed root of 0. So my gut tells me that the domain, and we'll check it, probably is all real numbers, or -infinity to infinity. We're going to plot it in a moment. Range gets a little tricky, so let's go ahead and just graph. I'm going to sketch my axes. I'm going to say y is equal to, now I'm typing in an open parenthesis, x squared minus 16, close parenthesis, raised to the open parenthesis, 1 divided by 3, close it. And I'll say zoom 6 again. And here's the graph I'm getting. I get something that looks like this. And we'll talk more about even functions later in the course, but this is called an even function. And the way you can determine if it's an even function or not is if you look at the graph, is it reflection symmetric over the y-axis? In other words, if I took this side and moved it, reflected it over the y-axis, and took this side and reflected it over the y-axis, would I get the same graph? Yes, I would. It's even. Now, think about the domain. All real numbers. Our gut was correct. The range, not not so much. We've got some work to do here. This is heading towards infinity, and this is actually heading towards infinity as well. So we're going up forever without bound, up forever without bound, but notice we have this local and actually global minimum here. So the question is that we should be asking ourselves is, what's the y value there? Whatever it is, our range is all real numbers greater than or equal to that, and we say equal to because it's a point. It's an ordered pair. It kicks out an output value. So how do I find that value? Well, look where it occurs. It occurs at x equals 0. So if I put 0 into the equation, sorry to switch screens on you there. If I put 0 into the equation, then I can get the output. So let's do that. 0 minus 16. Let's see, 0 squared minus 16, yep, raised to the 1/3 power is the same as the cubed root of 0 minus 16. It's the cubed root of negative 16, which is a value. It's an exact value, as we've been talking about in class. We want to get comfortable working with those. So my range is y is greater than or equal to the cubed root of negative 16. Another way to write that would be cubed root negative 16 up to infinity, bracket, because we're including it, parenthesis, because we don't include that. All right, I hope that helps. Covered a lot. Sorry for the long video. Thanks for your patience. That's all I have.